not use that open circle. Okay, so we're doing the A part. The A part says we're going to do F composite G, and it's got that open circle there. So if you would, in your mind, think of just F parentheses G of X, I think that might be a little bit easier for you. All right, so what we're really doing is we're putting one function into the other. Let me say that again. That's what a composite function is. It's where you take one function and you actually put it into the other function. So in F composite G, we're taking G of X and we're putting it into F of X. We're taking the G of X function and we're actually putting it into the F of X function. So what does G of X equal to? 3x plus 4. So we're going to take the 3x minus 4 and we're going to put it into F of X. So what it means to put something into a function means wherever you see x in F of X, you're going to put in 3x minus 4. Okay? So F composite G of X is the same thing as F of G of X, which is the same thing as taking your G of X and putting it into your F of X. Isn't that interesting? So for those of you that still have no idea what I'm talking about, here's another way that it could be written. F of 3x minus 4. Let's see if any light bulbs might come on at this point. Some of y'all will be able to do some of these without any work because you just understand what I'm saying. Some of you, I may have to say it 100 times.
So you're just going to take G of X and put it in the parentheses.
It's actually like you're going to go, here's G of X, and we're going to put it into the X and the F of X. We're taking the whole 3x minus 4, and we're putting it into the X and the 5x plus 2. Taking the whole 3x minus 4, because that's G of X, and we're putting it into the F of X function. So it looks like this. 5 parentheses. What are we going to put into that X? 3x minus 4. And then we still have to add 2. So F composite G of X means we're taking the G of X function, we're shrinking it up, and we're putting it over into the X or the X's that are in F of X. And then you just distribute the 5 and combine like terms. It's just really, really weird to begin with, and some people just turn me off, and they go, oh, I can't figure it out.
When you're done, do you do F of X equals what you have left?
No. It's really evaluating a function, except what you're putting in is another function. Okay? And that's what the A part's asking you to do. Okay? The B part's asking you to switch that up. The B part's asking you to do G composite F. So that really means G parentheses F of X, which really means G parentheses 5x plus 2. So in this problem, because it's G composite F, what we're really doing is we're taking our F of X and we're shrinking it up, 5x plus 2, and we're putting it over into the G of X function. So it's going to look like this, 3, and instead of the X, we're going to substitute in 5x plus 2, and then we're going to subtract 4. So our F of X function is actually going to go into our G of X function. We're going to distribute the 3 and then combine like terms. C is going to be a little bit easier because I actually have F composite G of 2. So some of you might be able to do the C part in your head. I would suggest that you may want to rethink it as without that little open circle. And you're thinking of it as F parentheses G of 2. So because it's G of 2 and not G of X, start with your G of 2. That means into your G of X function, wherever you see an X, you're going to put in a 2. And I think you can do that part in your head. So we're going to do this little G of 2 first. So So that means that 2 is going to come right here. You're going to do 3 times 2 is 6. 6 minus 4 is 2. So G of 2, and you're not always going to come up with the same number. That just happened there. G of 2 has a value of 2. So now they're asking you to find f of 2. So now you're going to go into your f of x function. Wherever you see an x, you're going to substitute in a 2. So it'll be 5 times 2 is 10. 10 plus 2 is 12. We'll do a couple of these. You're probably...
Will you back up just a little bit? Wait, can you just like work that out? Like,
No, I'll go to the next one and you'll catch on to it the next time. Okay? All right, moving on. Example 2. Sorry guys, if I had 3 hours to teach this lesson, I could answer every single question, but I don't have 3 hours. Okay? Sorry. There's 2 whole chapters I don't even teach in this class that I'm supposed to. You'll get those in pre-cal. Example 2. Okay, we're going to start off with f composite g. I'm going to go ahead and write it as f parentheses g of x. I'm going to do the same thing in this one, so maybe it'll help you with example 1. So that really means I'm doing f of what? 2x squared minus 9. So that really means I'm taking the g of x function and I'm putting it into the x in the f of x. So it's going to look like this. 7 times 2x squared minus 9 in parentheses plus 1. Distribute the 7 and combine like terms. All right, we're going to swap that around and we're going to do g composite f, which is really g parentheses f of x close parentheses, which is really g of what? 7x plus 1. So now what this problem is asking me to do is asking me to take the 7x plus 1, my f of x, and it's asking me to put it into my g of x. So this is going to take a little bit more algebra because you've got to do 2 parentheses 7x plus 1 squared minus 9. You're taking your f of x and you're putting it into your g of x. Now I can't just distribute the 2 because I have something that is squared, and I have to do the square before I can multiply. So I'm going to do square double square, and I'm going to get 49x squared plus what? Abby says 14x plus 1 squared is 1 minus the 9. Now I can distribute my 2, and I get 98x squared plus 28x plus 2 minus 9. And then I can combine like terms, 98x squared plus 28x minus 7. So the concept is the same. The algebra will get harder, but the concept is the same. Now, it never fails. A and B are supposed to be harder, but when we get to C, C is supposed to be easier because it has a number, but I don't know why. Maybe it's because it's easy. People get confused on C. But C says we're doing F composite G of 2, which is really F parentheses G of 2. So I'll go a little bit slower on this one. So we can actually find G of 2. It's a number, right? We can actually find G of 2. We can actually find the value of G of 2 because it's not G of x, it's G of 2. So we're going to go over here to our G of x, and wherever we see an x, we're going to put a 2. So we're going to do 2 squared is 4. 4 times 2 is 8 minus 9 is negative 1. So G of 2 is equal to negative 1. All right, so you're going to replace G of 2 with negative 1. Now the problem reads f of negative 1. So that means you go to your f of x equation. Wherever you see an x, you're going to put in a negative 1. So that's 7 times negative 1 plus 1. 7 times negative 1 is negative 7, and negative 7 plus 1 is negative 6. If you need to write that down, you can, but I think you can plug those numbers in. So the C part's supposed to be easier because you're not plugging in a function, you're just plugging in a number into your g of x, getting that answer, taking that answer and plugging it into your f of x. Okay? For the sake of time, we are not going to do number 3. It is just like example 1 and 3. It's a little bit harder, but the concept is the same. So let's look at example 4. We got some square roots going on. So in the A part, we're doing f composite g of x. So that means we're putting f into g or g into f. We're putting g into f. Let's see if we can we were writing down every single step in the first 2 examples. Let's see if we can actually just put g of x into f. Does anybody know what that would look like? Square root of x plus 2. Ding, ding, ding. Can you simplify the square root of x plus 2? No, so that is the answer. Now we're going to swap that around. We're going to do g composite f of x. So this time that means we're taking f of x, which is the square root of x, and we're putting that into every x we see in our g of x. So what would that look like? The square root of x all by its little lonesome self, and then plus 2. Alright, and C says f composite g of, are we still under the same directions? Yep, 2. So this time we're actually going to plug in a number here. So we're going to do g of 2 first. So in your head, go to the g of x equation where the x is, put into 2, and simplify the function. What is g of 2? 4. And what is f of 4? 2. Alright. For the sake of time, we're going to omit number 5. Alright, the directions are going to change here. The first set of directions were consistent. The second set of directions say the domain of the composite function f composite g is the set of all x's such that x is the domain of g. And I have typed in domain of your input when you're finding the domain of a composite function. Now we're going to go back and talk about domain. When we're finding the domain of a composite function, we have to consider the domain of the input and we have to consider the domain of the output. Did I write domain input, output on yours, or did I just type that on mine? All right, please write that down. When you're finding the domain of a composite function, hey, it's on the front, I think maybe, part of it. But write it right here. When you're finding the domain of a composite function, you have to consider the domain of the input, that's what you're putting in, and you have to consider the domain of the output, that's what you're getting out. And I'll explain clearly what's the input, what's the output when we look at a problem. Alright, so example 6 says all you have to do is f composite g, and then the B part says find the domain of f composite g. So the good part is I don't have 3 problems to do. So I'm doing f composite g, so that's really f parentheses g of x. So that means I'm putting what into what? I'm putting g into f. I'm putting the g of x function into f. So it would look like this. It would be 5 over 1 over x plus 4. So that's what that's going to look like. If I do f composite g of x, that means I'm taking the g of x function and I'm putting it into the f of x function. So is it simplified? No, it's not simplified because you have this little fraction inside of a big fraction. So I'm going to multiply the top and the bottom by what? X. So x times 5 is 5x. X times 1 over x is 1 plus x times 4 is 4x. Okay? Now that's my answer. That's F composite G. All right, that's my answer. Now they want to know the domain. So when we do the domain of a composite function, we have to consider the domain of the input. What did we put in? What was it that we put in for x? 1 over x was our input. 1 over x is what we were actually putting in. We were putting g of x into f of x. So tell me about the domain of 1 over x. X cannot be 0. So if you'll just write x cannot be 0, we know in our input x cannot be 0, so just make a note of that. And now we're going to go look at our output. Our output is our final answer. It's what we're getting out of what we put in. So our output is 5x over 1 plus 4x. Okay, do you see any x's in the denominator of your output? Yes, there is an x. You got to think a little bit hard about what can x be that multiplies times 4 that adds to 1 that gives you a big fat 0 in the bottom. There is something that x cannot be. Negative 1/4. Everybody get that? 4 times negative 1/4 is what? Negative 1, and negative 1 plus 1 is 0. If you can't figure that out in your head, you're going to take 1 plus 4x and set it equal to 0, and you'll solve for x, and you'll get negative 1/4. So when we're writing our domain of our composite function, you have to consider the domain of the input, and you have to consider the domain of the output. So in the input, x cannot be 0, and in the output, x cannot be negative 1/4. So now you can write your domain. Those are the only two values of x that cannot exist. So how many intervals are we going to have? 3. Negative infinity 2. Negative 1/4. Parentheses. Union. Parentheses. Negative 1/4 to the next biggest excluded value, which is 0. Parentheses. Union. Parentheses. 0 to positive infinity. There are 2 sets of directions to your homework. Okay, we covered the first set. That's when you were doing F composite G, G composite F, and then F composite G of 2. And then the second set is just going to ask you to do F composite G, but then it's going to ask for the domain. So you got to consider the domain of the input, and you have to consider the domain of the output. Okay? Any general questions? We're not going to do the last few. All right, let's go to 9 and 10 because they have different directions. So we can omit 7, omit 8. Let's go to 9 and 10 because the directions change here. Express the given function h as a composition of 2 functions f and g so that h of x is equal to f composite g of x. Makes a lot of sense, right? Let's read it again. Express the given function h. So they're giving you the answer, okay? They're giving you the answer of f composite g. Like that's the answer. That's what you get when you do f composite g. So see right here where it says h of x is equal to f composite g. So once you do the composition of f and g, it actually gives you example 9, h of x equals 2x minus 5. Alright, so I'm just going to tell you what the answer is to this one. So what are we putting in? F of x or g of x? G of x is your input. So what looks like it's inside that h of x function? 2x minus 5. That's the inside part. That's the guts. That's what you would put inside. And you're putting that into something that is being cubed. So f of x is going to be x cubed. It's like you're creating 2 functions that if you did the composition of f and g, it would give you h of x. Okay, look at example 10. So again, g of x is what you're putting in. So what looks like the inside part of h of x? The 3x minus 4, that's going to be your g of x, because g of x is what you're putting in, and it looks like we're putting that into the absolute value of x. Good. So in this last part, they're going to give you the answer, and they're going to ask you to go back and create two functions. There are different answers that you can get for these, but most of us will kind of come up with the same thing.